All right, so here we are with our person class interface, the 30 fields, a member function, print name and age, and a constructor that takes in arguments and assigns the values that are stored temporarily in those parameters to these fields. I want to make a note about the names that I've given these parameters, p first name, p last name, and p age. Actually, you don't even need to specify up here what their names are going to be. We just need to know up here in the function prototype, it turns out all it needs to know is that the first argument is going to be a string, the second argument is going to be a string, and the third argument is going to be an integer. And the reason is that we're going to define what those names are later. At this point, we just need to know how the constructor is going to be called. It takes in a string, and an integer. When we actually implement that constructor, as we've done here, here's the implementation of that constructor. Here we give this first parameter, that's a string, a name. I've called it p first name to match the name of the field first name. I've prepended a p to remind us this is just the parameter that's called first name. It's not the field first name. It's not the instance variable, the class. It's just a temporary local variable, at least in my definition, is a local in scope. It's only remembered as long as that constructor is being run. After the constructor is run, it disappears. I could call it anything I want. I could call it string x, y, and z, and then I just have to change these accordingly. Remember that. So there's nothing special about those names that I've given it. This code is going to work just the same as before. So there's nothing special. It's just the order of the arguments determines the order or which variables that these arguments get stored in temporarily. Mark gets put in x temporarily because it is the first argument, and then the second argument, separated by a comma, gets put in the second parameter that happens to be called y. So there's nothing special about the names that I gave it before. I just like to prepend the letter p and then call it the same name as the field that it's eventually going to go into. Let's undo all these changes. So it's the same as it was before. All right. That's what I wanted to clear up there. Okay, let's move on. And we said before that we could create a new person object just by calling this noArgument constructor. But it turns out we can't do that anymore. It says, let's see what this variable is. I guess you can't see all of that, but it says that no instance of constructor or person matches the argument list. The argument list being this empty argument list that has no arguments. We have not created a constructor that takes in no arguments. Our constructor takes in 3 arguments. But wait, didn't that work before, right? Before we had this constructor, let's comment this constructor out. This code would work. And this code wouldn't work because here we hadn't yet created a constructor that takes in 3 arguments. But we got this no argument constructor, which is called the default constructor, for free. It turns out that as soon as you start writing constructors yourself, so let's uncomment this. There are errors on these ones now. Let's uncomment that and uncomment that. As soon as you write a constructor yourself, oops, you don't get the default constructor for free anymore. So we need to redefine that. So let's create a no argument constructor ourselves that will create a blank person. So we're going to do what's called overloading the constructor. We're going to create a special function with the same name but with a different parameter list. This one takes in no parameters or no arguments and has no parameters that are temporarily stored inside. We're going to implement it in the same way as we did our first one. We're going to say it's part of the person class, so it has access to all the fields of a person, and it's going to be called person, the same name as the class, because all constructors are named the same as the class itself, and it's going to take in no arguments. We are implementing this function prototype up here, this constructor prototype. What should we do there? Well, we could leave it blank, and that would be okay. Now we can create a person with this syntax now. No errors here. However, if we try to print person P3's name and age, compiling, we end up with the same problem again. So let's come up with a default name of that person and age for a person. If we just create a person object, let's not make it blank. There's two ways we can do that. We can actually write some code inside here that assigns values to those fields when we create a new person without specifying any arguments. Or we can actually put it up here. We can say that this person's name is going to be John Doe, and they're going to have age 0. Now whenever we create a person object using the empty constructor, which doesn't do anything, we still have default values John Doe and 0. Now when we call this constructor, when the person is first created, initially, for a brief instant, they're going to have a name John Doe and 0, but then when this constructor runs, it's actually going to take in those arguments and assign it to the field. So even though that person, when they were first created, had name John Doe, by the time we actually finish running the code, it's become a person that's named Mark Zuckerberg. So you'll see that it prints the name and age of this person correctly, but this one here that's created with no argument constructor, nothing happens in this no argument constructor, so it's going to retain those defaults. Compiling, we got the constructor. John Doe is 0 years old. Now why would we want to do that? This is a matter of convenience. Sometimes we might want to create a person and tell them their name and age immediately. Sometimes we want to give only pieces of the information, or none at all initially. We just want to create the person first, and then we can set their name and age later, right? We can use that dot operator, say their age is 30 actually, and we'll set that information later. So this is a matter of convenience. We don't always want to create a person and tell them their age and name immediately. We'll see more examples of that later on. Take my word for it right now that it can be convenient to do that. So the other way to do this is just an option, and you'll find uses for these different options on your own as we have different problems. I can't show them all with this one example. Let's take these pieces of information out here, and we're going to say that the first name field gets the value John. The last name gets the value Doe. And age, if no arguments are given to us, it's going to be 0 age person. You couldn't see that. Sorry about that. I just wrote that line. And finally, we'll run this code, and it's going to run exactly the same as before. John Doe is 0. So what we did this time is we overloaded the constructor. We created another function with the exact same name, but a different parameter list. This one had 3 parameters, a string, and an int. This one had no parameters. We implement the constructors here and here. Next time we're going to create another member function that shows you that even if we created a person with the no argument constructor, we can still set their name and age all in one go. So we'll create a function in order to help us do that.